Hello everyone. So this is the third video of the concept learning of data science from Python. So our third topic is exploratory data analysis or graphical data analysis. So as we all know that understanding the data through graphs or through visual effects is pretty easy than from a particular numerical basis. So for example, such as a hypothesis is, do cell phone users have higher rate of positive responses than landline users? So there is a hypothesis. Hypothesis of this particular data set could be carried out using either classical statistical methods or using cross-validation method of data science, which we will learn ahead. So on the other hand, the client or the analyst do not have any salient or prior notions about what the data might uncover. So in such cases, they would prefer to use exploratory data analysis or graphical data analysis. So EDA, the short form of exploratory data analysis, allows user to use EDA allows user to use graphics to explore the relationship between predictor variables and the target variables. So as you all know that the bar graph or the histograph, these are all types of graph which we use to show the relationship between two variables. Similarly, EDA also allows user to use graphics and tables to derive new variables that will increase predictive value. And it also allows user to use binning productively to improve predictive value. So now we will imply these things to Python. So our first task will be to make the bar graph using Python. That was just window. So here we are creating this particular bar graph of data which I took from Kaggle, method of Kaggle, but also took this data. So we are importing our first package panda, which we will use. Then next we will read the CSV file. So let us continue into panda command. That run. Yes. So next we will load this particular CSV file here, and we will store the data of the CSV file into data variable. Now we will use a cross-tab function from panda. So this cross-tab will create a cross table which will consist a cross table of two columns. So first we are taking the column of data from data loan. So let me show you the data table first. Yes, so here this is the data. So we are taking this column loan, which has input yes and no. So if they got loan, yes or no. And the next column we will take in will be the marital status. So we will predict that if the person is single, married or divorced, how this will affect that they will get loan in yes or no. So let's go back to our Python IDE. Yes, so here we will create the particular cost table. So when the cost table will be created, we can see how the data will be shown here. So let's check this, and this command will be run. Okay, so we will type the variable name, cross tab underscore 01 it is. Yes, so here is the marital status and the condition of loan yes or no. So this will show the number of responses connected to these two, divorced and yes, divorced and no, and similar for married and single. We got the cross tab data. Now we will plot this. So we are doing plotting this on bar graph. So cross tab dot plot and kind equals to which type of graph you are using. So here we are using bar graph. It's stacked equals to true. So when you will run this will create graph. So here we will plot the graph here. This graph shows the data in very easy to learn form. aliases that known. We will create next cross table, which will imply the connections between loan and education. So how the loan and the education of the particular person is connected. So when you will run this particular line, it will create cross table loan and education. This will create this type of cross table. We have primary, secondary, tertiary, and unknown. There are four categories of education, and this is the cross table we have created. So now we will round up the cross table. So dot cross table two dot depth cross table two dot sum zero x is equals to one. This will show the percentage. So here it is showing the percentage of the particular data that we got up here. We can do also this for cross table one. This is the percentage we got. This is how we can create bar graph. The next topic is contingency table. So to help quantify the relationship between a categorical predictor and the target, we can construct a contingency table, which is cross tabulation of two variables and contains a cell for every combination of variable values. So the usual practice is to have the target variable representing the rows with the predictor representing the column. So for EDA, it is also helpful to include column present percentages. So this is how we can create continuous table. This is the round function here. This is called the contingency table. This is called a contingency table. The contingency table is used to create the percentage that we got up here, the data we got up here. We can convert them into percentage. So we are converting the XSS into 100. This will create the data into percent. Now the next topic is histograms with response overlay. So histogram is a graphical representation of frequency distribution for a numerical variable. Most customers range from say mid 20s about 60 years of age. So they, we will create the histogram here. This is the file. To imply histogram, we have to run this particular command, which will import matplotlib.pyplot. Matplotlib will be used to plot histogram, and we will naming it as pnt in our further use. So we are taking here the age as yes. This particular variable is taking age as yes. So this will take data from data.loan equals to yes. So wherever the column of loan says yes, this data will take that particular data of that column into age yes, age underscore y. And similarly, this will do for no. So we will run this and this. So these two will be run. Now our next line shows that we are plotting histogram, plt.histogram, then our x-axis and y-axis. So if if they're getting loan yes or no, we are giving that variable one by one. Bins equals to 10, stack equals to 2. So this will give the output which will catch here to these three variables n comma bins comma patches. When you will run this, this created this histogram. So then we got the data. Now we will uh, responses. We will now we will give this histogram response overlay. So for response overlay, we give this response yes and response no, and title and label. Label to particular x-axis and y-axis. So for x-axis it's age, for y-axis it's frequency. So we have given it frequency. And now we will run this particular again. Here n is the height of the histogram bar, and bins are the boundaries of each bin in the histogram. These two variables are being plotted in the histogram. N has two series of numbers. The first series is for the first variable, and the second one is for the second variable. The first number in each series is the height of the first bar for each variable. So, our next topic is binning based on predictive value. So, some algorithms work better with categorical rather than numeric values. So, it may be useful for analysts to use binning to derive new categorical values variables based on how the different sets of values of the numeric predictor behave with respect to the response. So we can binning means we can categorize this particular data by doing this as we will bin the age group less than 27 in particular bin, which we will create as one. We will create two to create age group between 27 to 60, and three for 60 and up. So we can create uh, more basically precise data, more understandable data according to the binning of ages. So for that we will go here and import numpy, and then this particular n underscore table variable will collect the column stack n0 from n0 to n0 and n1. So as we know here that n we got this n from the dot histogram function. So this dot histogram will dot hist basically here from here we got n, and as I told you n represents the height. So as we have two variables, so two variables n0 and n1 will be column stack or column height. And normalization, and norm equals to n underscore table. So here n underscore table, this is what we got up here, divided by n underscore table dot sum x is equals to 1. So then we will pass here two data. So for binning, we will create a column data age underscore bin. So this column will be containing the data from age where bins equals to 0, 27, 60.01, 10. So this 0, 27 will be our first age, 27, 60.01 is our second group, and 60.01 to till 100 is the third group. So these are the bins, and the bins we are creating is through age column. So this dot cut function will cut through the data of age and categorize them into particular these bins. Now we will create labels. These labels will be used by us in the histogram labels, and we are creating another cross table. So this particular cross table will consist of two columns, age underscore bin, which is created here, and consists bin data, particular single line. And we will run this now. So most of it is not shown here. But now we are creating a cross table, as I told you. The cross table has been created, and now we are plotting the particular cross table. So dot plot kind bar, and slide equals to 2. Title is bar graph, and then we can run this. This will create a graph. Here we got the x-axis and y-axis. The x-axis is age underscore bin, which is mentioned here. This is 127 age, and here this we got the response overlay. So this is our today's video. Thanks for watching.